Let's look at some problems, and I'll give you the worksheets dealing with 8.2. It's called Appendix 2. It's from your appendix. It's not the organ appendix. It's the appendix in the back of the book. Okay, so let's look at number... All right, just kind of review. Let's look at number 14. So this is 14 on page 1228. All right, so you have x is less than or equal to 4 and x is greater than or equal to negative 2.
Is this not 4?
No, this is appendix A2.
Okay. Wait, is it less than or equal to 4 or 0?
Less than or equal to 0. Did I say 4?
Yeah.
I meant 0. I'm sorry. 0. 0. Okay, now, in this particular case, the variable is already by itself. All right, so in the situations you're going to see, though, the variable won't be by itself for the most part in those worksheets. So you have to solve for x just like you did before, just like you'll do on test number 2. So the work you want to show at this point, once you get the variable by itself, the work you want to show is this. You want to graph each one individually. Graph each one individually. So when I graph the first one, so this is the first one right here. Here is 0. Well, let's put 0 here. Here's 0. And so when you graph x is less than or equal to 0, when you solve x is less than or equal to 0, what is it you're graphing when you're solving x is less than or equal to 0? You're graphing the solutions. That's what you're graphing. You're graphing the solutions. So what are the solutions to this inequality right here? 0 and what else? Any number less than 0. Now on 0, do I use an open or closed circle? Closed, because I can use 0. 0 is a solution, that equal sign. And I want to shade in all the numbers that are less than that. Okay, so that's the solution to that first one. Then we graph the second one. And when you graph it, you do this part right here, the graph part, when you get x by itself. All right, so we're going to do the next one, and we're going to line the numbers. So this is 0. Negative 2, let's say, is here. Make sure you align them just like you did in the first one. So this time I want these solutions that are greater than or equal to negative 2. So where do I put the circle? Open or close? Because of the equal sign. Negative 2 is a solution. And I want all the numbers that are greater than that. Okay, so you're going to use this. Once you graph each one individually, you use that to come up with the graph for your answer. So on the worksheet, there's only one graph. That's the graph of the solution set to the problem. The workspace, the space between, is where you're going to put these two individual ones. All right, so if this is 0 and this is negative 2, where are my solutions? Between negative 2 and 0. So remember the word and, you're looking for intersection. So remember when you look at the word and, whatever number you use has to satisfy the first inequality and the second. Hence the word and the second. So if you look at this, you'll see why 5 is not a solution. 5 is greater than or equal to negative 2, but what's the issue? It's not less than or equal to 0. Negative 8 is not a solution. Negative 8 is here. It's not a solution. Because even though negative 8 is less than or equal to 0, what's the issue? It's not bigger than or equal to negative 2. So the only numbers that are less than or equal to 0 and at the same time greater than or equal to negative 2 are which ones? Where the two graphs overlap between negative 2 and 0. So on negative 2, do I use an open or closed circle? Closed because of the equal sign. And then -2, I'm sorry, zero's, well, 0, close, is the equal sign right here. And so my graph will be all the numbers between them. No arrows because it only goes from -2 to 0.
So question then, so every time we work a problem like this, we're gonna have to do the first 2 graphs
Yes.
and then this complete.
Then the graph that's going to show up on the test or on the worksheet. That's the graph you're going to put the solution set on. All right, so that was 14. Okay, let's look at this now. So this is 18. Okay, so in 18, you have x is greater than or equal to -4. And, so another compound inequality with word and. So and means intersection. All right. So in this case, the variable is already by itself. So once you get the variable by itself, then you go and you graph each one individually. So let's go to the first one. So let's say -4 is here. And for the first one, what are the solutions to x is greater than or equal to -4? Anything greater than or equal to -4, right? So closed circle going which way? To the right. Now remember, you're graphing because you can't list them. It's not like the equations. When you solve the equations, you didn't graph the solution set, although you could have. But we don't graph it for an equation. We just list the 2 solutions or the 1 solution, whatever it may be. But here, there are how many solutions? An infinite number. So you can't physically list them, so you have to graph them. All right, now let's look at the next one. X is greater than 1. So x is greater than 1. Now, where am I going to put 1 on this number line right here? Can I put 1 right here? No. You got to put it to the right of -4, so you got to put it somewhere around here. So you got to make sure it's aligned. If it's not, your graph's going to mess up. You're going to shade in the wrong solutions. So x is greater than 1 this time. Open or close?
Open.
Right. Going which way? To the right. Greater than. You want all the numbers greater than that. All right. And since this was an and statement, what are you going to shade in? Where do they overlap?
At the 1.
1 to what?
1 to 2.
1 to infinity. So your answer, so you can put 1 in the number line, because that's where it's going to start. Open or close circle at 1. Open because there's no equal sign here at 1. See that was strictly, remember there was an open circle. And I'm shading every number that's to the right. So that's your solution set. So the solution set in terms of the graph would be from 1 to infinity. And you can check. So let's see why 0 doesn't work. 0's not shaded, right? 0's not shaded. Let's see why 0 doesn't work. Is 0 greater than or equal to -4? Yes, but what's the problem? It's not greater than 1. So that's why 0 is not shaded. Let's see why 7 is shaded. Let's see why we're saying 7 is a solution. Is 7 greater than or equal to -4? Yes. And is 7 greater than 1? Yes. Okay, so that's your solution set. Now, as an interval in interval notation, what would that look like? Because I think I asked for the interval as well. Parentheses, 1, comma, infinity, parentheses. Okay, over here, what would be the interval notation over here? Bracket, -2, comma, 0 with a bracket. That part, in terms of the interval and the graphs, are on test number 2. All right, now, let's look at number 20. Number 20. It's not that difficult as long as you remember how to solve the previous inequalities. The worksheet you are turning in, what is it, 9.7s? I think that's next class period, or the class period. No, you turned in 9.4s today, right? 9.4s. Oh no, the 9.7s you already turned in. Yeah, I'm sorry, you already turned that in. Because we did 9.7 before we did 9.4. Okay. Because that's on your test. All right, number 20. You have x plus 2 is greater or equal to 3. And 5x minus 1 is greater or equal to 9. Okay, so that's the problem we have. It's not difficult. Don't make it difficult. You're going to do it just like you did for test 2. For test 2, if all I had was this one right here, what would you do? Get x by itself. On test 2, if all I had was this, what would you do? Get x by itself. You'd solve for x, right? And then you graph each one. Well, that's what you're doing here, except this is a compound inequality, not a simple inequality. A simple inequality would be 1. Compound inequality is where you have 2 joined with either an and or an or statement. So let's solve each one individually. How to get x by itself here? Subtract 2. And so x is greater than or equal to what? 1. Now, make sure you understand what you just found. So x is greater than or equal to 1 means that you just found the solution to which of these inequalities? The first one. That's what you found. So any number greater than or equal to 1 is a solution to that first inequality. But that's not the solution to the compound inequalities. It's a solution to this one. Okay, now how do you do this one? Add 1 to both sides. 5x is greater than or equal to positive 10, right? And then how to get x by itself? Divide by 5. So x is greater than or equal to 2. So x is greater than or equal to 2 is a solution to which inequality? The second one. All right. But I've got to find the solution to the original compound inequality. So that's where I draw the 2 separate graphs. And I look, since this is an and statement, I look to see where the 2 graphs overlap or they intersect. All right, so let's do the first one. So x is greater than or equal to 1. Now remember, I'm dealing with 1 and 2, so I'm going to put 1 and 2 in that number line. So let's say this is the 1 and this is the what? 2. Okay, so x is greater than or equal to 1. What will I put at 1? Closed circle going which way? To the right. Okay, now remember, all you're doing now is just graphing each one so you can see where they overlap. Okay, over here, x is greater than or equal to 2. So here's 2. Open or close? Going which way? The right. And so therefore, the graph that's on your worksheet or in the test that looks like this, what are you going to put there? What are you going to shade in? All the numbers that are what than 2? Greater than 2. So remember, it helps if you shade in where the solutions are. That's where they are, right? Because that's where the 2 graphs do what? Intersect, overlap. Okay, so it'll be 2, open or closed? Closed, because the equal sign. Going which way? To the right. So there's there's the graph that you would mark. And so in terms of interval notation, what will be your solution? Bracket, 2, comma, infinity, parentheses. And that's all that is. So in order to be able to do this, you've got to be able to do the 9.7s, which you've already turned in a while back. Okay? All right, so that was 20. All right, let's look at 22. Okay, so in 22, you have x plus 2 is, oops, sorry, 2x plus 4 is greater than 0. Greater than 0. Greater than 0. And then 4x is greater than 0. So 2x plus 4 is greater than 0. And, it's an and statement. And 4x is greater than 0. So first of all, is x by itself in either case? No, so you got to solve each inequality individually. So you're solving each one individually. So how are you going to solve this one? All right, so 2x is greater than a negative 4. What's the next step? Divide both sides by 2. Now remember, some of you forgetting that when you divide and multiply by a negative number, you got to reverse. So when you get back to your worksheets on the 9.7s today, make sure you look at that part. So x is, do I need to reverse it? No. So x is going to be greater than negative 2.
So
So
why didn't you have to reverse it?
why?
Not dividing by
Because I'm not dividing by a negative number. All right, so when I graph the solutions to that one, remember when I graph it, I'm only graphing the solution to that first inequality. So let's do the next one before I start graphing both. How do you get x by itself over here? Divide by 4. 4 divided by 4 is 1. 1 times x is x, so x is greater than 0. All right, so I'm going to put negative 2 first and 0 next on the number line. So when I graph the solutions to the first inequality, I'm going to put an open circle because there's no equal sign. Where? Going which way? To the right. And then for the next one, x is greater than 0. Now remember, I just shaded the solution to that first inequality. That's not the solution to the compound inequality. It's only the solution to the first. That's test 2 right there. When I graph the solution to x greater than 0, that's the solutions to this inequality. So here's 0, open or closed? Open going which way? To the right. Now remember, I just graphed the solution to that second inequality. Now I've got to graph the solution to the compound inequality. And that's what that graph is on your worksheet. That's the one you put there. So where are the solutions? 0 to infinity, because that's where it overlaps. So your answer, right, let's do the graph first. It'll be 0, open or closed? Open, because there's no, you see right here at 0, there's an open circle. Going to the right. So as an interval notation, what would the solution be? And you can quickly check this. So if you pick a number that's in here, let's say 1. 4 times 1 is 4, and is 4 bigger than 0? Yes. 2 times 1 is 2. 2 plus 4 is 6. Is 6 bigger than 0? Yes. Now let's see why negative 1 does not work.
Is that an infinity sign next to it?
That's infinity. 2 times negative 1? Negative 2. Negative 2 plus 4? 2. Is 2 bigger than 0? Yes. But there's a reason why it's not a solution to the compound. Let's check the next one. What's 4 times negative 1? Is negative 4 bigger than 0? No. So that's why it's not shaded. All right, let's look at 24. 24. So remember, and inequalities, you look for where they intersect. And notice that you need to do the two graphs individually to see where they intersect. All right, 24. You have negative 7x is less than or equal to negative 21, and x minus 20 is less than or equal to negative 15. All right. So let's look at the first one.
Divide both sides by negative 7.
All right, so you can divide both sides by negative 7. Now remember, when you divide by a negative number, multiply, you got to reverse this. So negative 7 divided by negative 7 is 1. So the solution to that first inequality will be any number that is what? Greater than or equal to positive 3. All right, the next one, how do you get x by itself? No, add 20, right? Add 20. Negative 20 and 20 is 0, so you get x is less than or equal to 5. All right. So then you're going to graph each one individually. So let's do the first one. X is greater than or equal to 3. Now remember, what I'm shading in are the solutions to that first inequality. So here's 3, here's 5. So at 3, open or closed? Okay. So remember, that part's on test 2. Going which way? To the right. So those are solutions to that first inequality. The next one? Closed on 5. Going which way? To the left. So these are solutions to the second inequality. But I need to find the solution to the compound inequality. It's an and statement, so what are you looking for in terms of those two graphs? Where the two graphs do what? Overlap, intersect. So where do those two graphs intersect? Between negative 3 and 5. That's where they, huh? I meant positive 3, yes, positive 3. Between positive 3 and 5.
So what do you do like this between the 3 and the 5?
What now?
Do you do anything different on the graph, or you just write it differently?
Yeah, you do that, the answer part right here. All right, so your answer, so on the graph that shows up, there's only one graph that shows up on your worksheet and on my math lab. And that's where you put where the two graphs intersect. So where do they intersect? Between 3 and 5. At 3, open or closed? Closed, because of the closed circle. At 5, closed. And I shade in which part? Between them. Right? So those solutions. How many solutions are in here? An infinite number. It's not just the whole numbers. You have your decimals, your fractions, all that's in there. So there's an infinite number. So that's why you can't list them. You have to graph it. Now, as interval notation, what will be your solution? Yeah. All right. So any number between 3 and 5, like 3.777761 is a solution. So any rational number and any irrational number in here works. Like today is, you probably heard pi day?
Yes.
Yeah. So pi is approximately equal to what number? 3.14. So is pi a solution to this? Yes, because pi is in here. Pi is an irrational number. It's not a rational number, it's an irrational number. So you can't write it as a terminating decimal or a decimal that repeats. That's what makes it irrational. Okay, let's look at, let's see, let's do number 54. Okay, 54, you have 2x minus 1 is greater than or equal to 3. And negative x is greater than 2. All right. So how do you solve the first one?
Add 1 to both sides.
All right, so add 1 to both sides. So I get 2x is greater than or equal to 4. Then I do what?
Divide both sides.
Divide both sides by 2. So x would be greater than or equal to 2. So your solution to that first inequality is any number that's bigger than or equal to 2. All right, let's go to this one. Remember, this is not x, it's negative x. So, and this also you can write as negative 1 times x, correct?
Yep.
All right, how do you get x by itself? Divide by negative 1. Right, so it says dividing by a negative number, I'm going to reverse this inequality symbol. So the solution to that second inequality will be any number that is less than negative 2. Okay? All right, so then you graph each one individually. So here's negative 2 and here's 2. Make sure you put them in order on the number line. So x greater equal to 2. So at 2, open or closed? Closed, going which way? To the right. So what I've just graphed, all these here that are shaded in are the solutions to which inequality? The first one. All right, but then I got to graph the solution to the second. So here's negative 2, open or closed? Open, going which way? To the left. So these are the solutions to which inequality? The second one, the one on the right. But I want to find the solutions to the compound inequality. Remember, this is an and statement, so you look to see where the two graphs overlap. Where do they overlap? Okay, so she said between 2 and negative 2. Is that correct? No. Where do they overlap? They don't overlap. The shaded parts are not above each other or under each other. So based on what you remember last time, we did one like this last time. So the empty set. So it means no solution, right? So does this compound inequality have a solution? Do we have any solutions here? No. So this compound inequality has no solution.
Draw the sign really big so I can see it.
Draw the what now?
That symbol really big.
I haven't done it yet. Okay, but I will.
Okay.
All right. So there's no solution, right? Okay. So now remember, there's going to be a graph, and then there's going to be something I'll say interval notation. Okay, so in terms of the graph, are you going to put anything on the graph? No, you can leave it blank. Leave the graph blank. But on the interval notation, I need for you to put something. So you're going to put either the empty set, which is this, circle with a slash through it, right? Or you can say what? No solution. Okay?
You put no solution on the test, that would be correct.
Either this or this. Okay? Okay, but now remember, my slide though, the way they have it, when you go to it, it'll say the solution set is, and then there's a blank for if there is a solution, or it'll say the solution set is, and then they'll have that symbol, meaning the empty set, meaning no solution. So which one would you choose? The empty set. Okay, 62. 62. As long as you know how to do 9.7, you can do compound inequalities. All we're dealing with right now is the word and. So and means intersection. Okay, that's an and statement again. All right, so 5x is less than or equal to 0, and negative x plus 5 is less than 8. Okay, so let's find the solution to that first inequality. How do I get the variable by itself? Divide both sides by 5. And so 5 divided by 5 is 1. 1 times x is x. So x is less than or equal to 0. So the solution to that first inequality is any number that's less than or equal to 0. And it kind of makes sense because if you pick a number that's not less than or equal to 0, let's say 3, what's 5 times 3? Is 15 less than or equal to 0? No. But any number that's less than or equal to 0 does work. So let's say negative 7. What's 5 times negative 7? Negative 35 is less than or equal to 0. All right, over here, how to get x by itself? Subtract 5 from both sides. So I get negative 1x is less than 3. All right, what's the next step? Divide both sides by negative 1. Since I'm dividing by a negative number, I got to remember to reverse this. So negative 1 divided by negative 1 is 1. 1 times x is x. But my solution would be any number that is what? Greater than negative 3, right? Okay. And you can check one of them. Let's check negative 1. Let's see why negative 1 works. Remember, this negative x means the opposite of x. So what's the opposite of a negative 1? Positive 1. 1 plus 5 is 6, and 6 is less than 8. Let's see why negative 7 does not work. Negative 7. What's the opposite of a negative 7? 7 plus 5 is 12. Is 12 less than 8? No. All right. Okay, so then we graph each one individually. So I'll put negative 3 first and 0 next. Okay, so x less than or equal to 0. On 0, do you use an open or closed circle? Open. Close, I'm sorry. Close because the equal sign. Going which way? To the left. X is greater than negative 3. On negative 3, open or closed? Open. Going which way? Greater than, so to the right, correct? All right, but remember, what kind of statement is this? And or are? Is that an and statement or an or statement? An and. In an and statement, you look for where the two graphs do what? Intersect. So where do they intersect? Between negative 3 and 0. So your answer, your solution graph, so you're going to say from negative 3 to what? 0. All right, now let's talk about the open and closed. At negative 3, is it open or closed? It's open because remember there was no equal sign right here, right? So negative 3 is not a solution. Negative 3 is not a solution to the compound inequality. All right, and then at 0, open or closed? Closed. So 0 is a solution, and the solutions are any number between those, right? So let's see why negative 3 is not a solution. What's 5 times negative 3? Is negative 15 less than or equal to 0? Yes. So why don't I have a closed circle here? You gotta look at this one. What's the opposite of negative 3? Positive 3. 3 plus 5 is 8. Is 8 less than 8? No, 8 equals 8. So that's why we don't have it as a solution. Because remember, it's got to satisfy both of those. Negative 3 only satisfies this one. It doesn't satisfy that one. So let's see why 0 works for both. What's 5 times 0?
0.
Is 0 less than or equal to 0? Yeah, it's equal to. What's the opposite of 0?
0.
What's 0 plus 5? Is 5 less than 8? Yeah. All right. Now, as inequality interval notation, what would you put? Parentheses, negative 3, comma, 0 with a bracket. All right, now let's look at this one. All right, example. Okay, suppose I had two x minus 1 is less than 5 and 3 minus 4x. I'm going to have to, I may need to change the inequality when I get to it, but let's just write this for right now. Let's say it's less than negative 5. Okay. All right. Okay, so notice that this is a compound inequality. If all you had on test 1 was this, that would be called a test 2 rather. That's called a simple inequality, just one inequality. Here, when you have two inequalities, the word and or the word are, it's called a compound inequality. Okay, solve each one individually. So let's solve the first one. Let's find the solutions to the first inequality.
We can add one of those lines.
So 2x is less than 6. Next step.
Divide by 2.
So the solution would be any number that's less than 3. Okay. Over here, what's the next step?
Subtract 3.
Subtract 3 from both sides. Now, what do I get on the left, though? Negative 4x is less than negative 8. Okay, next up. Divide both sides by negative 4. Since I'm dividing by negative number, I got to reverse this. So x is greater than 2. All right. So then I graph each one individually. So remember, the x is less than 3 was the solution to the first one now. So I'm just looking at the first one, the first inequality. So here's 2, here's 3. So x is less than 3. For right now, let's go make them both right here. Just this one, put less than equal to. Put less than equal to. Leave this one less than, put this one less than equal to. So it's supposed to be any number that's greater than equal to 2, right? And then here there'll be any number that's less than 3. Okay, so when we graph x is less than 3, open or close on 3? Going which way? To the left. X is greater than equal to 2. So here's 2, open or closed? Going which way? To the right. And the solution to the compound inequality would be where they do what? Intersect, and they intersect from positive 2 to, to 3. So 2 to 3. At 2, open or closed? Closed, because of the equal sign right here. And then at 3, since there's no equal sign, we're going to use open. So that's the solution. The solution set to that compound inequality. So any real number that's between 2 and 3 is a solution. And how many are there? An infinite number. There's an infinite number of real numbers between 2 and 3. You cannot count them. Okay? All right, as interval notation, you'd say bracket 2 to 3 parentheses. So when you get part A, and that'll be due a week from Thursday. So it's not due on test day. It'll be due on that Thursday, the day after the test. But look at this for a moment. This is what it looks like. This is part A. So the first one's easy because x is already by itself. Okay, so remember in this little part right here, so show work as presented in class, graph the solution set on that number line. So remember that final answer I always wrote, that third graph, that's what goes here. Is that clear? The two individual graphs, you put that here somewhere. So see, x is by itself, so it's easy to draw the two graphs. Easy to draw the two graphs and find out where they intersect. Here you're going to solve first, right? Get x by itself, then draw the two graphs, find out where they intersect. And the solution goes where? Here. That's where you put the solution. Don't forget, there's always a back, usually. Get x by itself, do the same thing. Get x by itself, do the same thing, and so on. Okay? If one of those, there's no solution, what are you going to do with the graph? Leave it blank, and what do you put in the interval notation? The empty set symbol, or you can say no solution. All right, so good. All right, so that's part A. Okay, so that's the and statement, right? Now let's look at an or statement. It's very simple. The or statement is very simple. Okay, so let's look at the simple example first. So let's say we had x is greater than 3 or x is less than 0. X is greater than 3 or x is less than 0. This time, what kind of compound inequality is this? Is it an and or is it an or? It's an or. So let's talk about what that or implies. If that was an and, the solution would have to satisfy both of those. That's what that means. So that's why we use the word intersection. Whatever solution you use, would have to work for both. With an or statement, let's think about this. What's the solution to that first one? No, 3 is not a solution because there's no equal sign. Give me a solution to the first one. Anything bigger than 3. Give me a number that's bigger than 3. 4. 5. 5 is a solution. So 5 works here. Does 5 work here? No. Okay, it does not. But remember, this or statement means this. The solution to this inequality has to satisfy either this or both. Okay? It satisfies one, so is it a solution to that compound statement?
Yeah.
Yes. So if it satisfies either one, then it is a solution. If that was an and statement, would 5 work? No. 5 would not work because 5 only satisfies this one. Does 5 satisfy this one? No. So this was an and statement. 5 would not be a solution. Since this is an or statement, it just has to satisfy how many of them? At least how many? One. An and statement has to satisfy how many of them? Both. Okay, good. So when you think of the word or, think of the word union. The word union. And in a little while, you're going to see the symbol for union because you may need it in some situations. Symbol for union. All right, so an or statement is a union. An and statement is an intersection. Union versus intersection. So here's how you deal with it. You do the same thing. You graph each one individually. So let's do the first one. X is greater than 3. The graph looks like this. So here's 0. Here's 3. Open circle going to the right. X is less than 0. Open circle going to the left. All right. And you can see why, if this was an and statement, there would be no solution, right? Because where did the two graphs overlap? They don't. So if that was an and statement, there would be no solution. But an or statement means anything that's shaded is a solution. Remember a while ago we said 5? 5 is in here, right? Is 5 a solution to this compound inequality? Yes. Is 2 a solution? No. Because is 2 bigger than 2? I'm sorry, is 2 bigger than 3? No. Is 2 less than 0? No. Is negative 3 a solution? Yes. Is negative 3 greater than 3? No, but negative 3 is what? Less than 0. So for an or statement, you're going to remember how we kind of shaded like this? Anything that's shaded is a solution. So when I go from left to right, it'll be from negative infinity to what? 0. And then from where? 3 to infinity. See how that looks? So anything shaded is a solution. So with an or statement, any number, and I'm going to go ahead and use the word real number. Any real number shaded is a what? Is a solution. Okay, so that's why it's important that when you do work, you do each one individually. And then you kind of do what I did. You shade in anything that's shaded. Okay, now here's what your answer will look like. So you read a graph from left to right. So I'm going from negative infinity all the way to what? I'm going from negative infinity. What's shaded? I'm going from negative infinity all the way to what? 0. You're not going to say 3 because it's not shaded between where? 0 and 3. Okay, so here's 0. So you're going from negative infinity all the way to what? 0, and at 0 you have a open circle. And then your solution's also where? From 3, open to closed. Open to what? Infinity. So that's your solution. So notice in this particular case, it's not always true with an OR statement, but notice that you have two separate graphs that are not joined somehow. They're distinct. So you're going from negative infinity to 0, and then from where? 3 to infinity. That's your solution. So that would be the one that you would draw. Now in interval notation, remember you graph from left to right. So as I go from left to right, what is the arrow pointing to? Which infinity? Negative. So you can say parentheses, negative infinity, comma, all the way to what? 0 with a parentheses because of the open circle. All right, leave some space here, and then you're going from where? Parentheses 3 to what? Infinity with parentheses. Now, on my math lab, remember, you're in the ones we did earlier, there were how many intervals with the and statement? Just 1. Here you have how many intervals? 2. It's not always true with an OR statement, but with this one it was. So this is a union of 2 intervals. Remember the word union? So this is a union of 2 intervals. So you're gonna use the symbol U to indicate the union. So that's a symbol for union. The U. So your solution set is the union of those 2 intervals, from negative infinity to 0, and then from 3 to infinity. Now, if you forget to put the union there, then it's fine, but mathematically it really needs to be there.
So you're saying you're gonna take off if it's not there?
I'm saying I'm not going to take off if it's not there. Mathematically it should be there.
That's out of character.
That's correct. Now, in my math lab, because the symbol for union is usually difficult to draw, I think they'll say just separate the solutions with a comma. So say separate with a comma, so you just separate it. You just put negative infinity to 0, comma, and then 3 to infinity. All right, so that's union. So let's look at this one. Suppose we had, okay, so this will be number 40. Number 40. Suppose we had negative 5x is less than or equal to 10, or 3x minus 5 is greater than or equal to 1. Okay, so it always helps you to first of all determine, is this a simple inequality or this is a compound inequality? Compound. The one in test 2 is going to be simple, meaning one inequality statement. Here you have how many inequality statements? 2. So it's a compound inequality. Then you got to ask yourself, is it an and or an or statement?
Or.
So then you got to remember, or means a union. Anything shaded is a solution. Okay? All right, but then you got to solve each one individually first, though. So what about the first one? Divide both sides by negative 5, but then I've got to remember to reverse. So my solutions would be any number that is what? Greater than or equal to negative 2. Now, I just found the solutions to which inequality? The first one. Now, technically, would that be a solution to the second one as well? Maybe, maybe not, right? But would that be a solution to the compound inequality?
Yes.
Yes, because remember we said, any number that's shaded is a what? Solution. Would negative 2 be shaded? Yeah, so is negative 2 going to be a solution to this compound inequality? Yes. But you can't stop there. You're going to see why. You got to do the other one now. Add 5 to both sides. 3x is greater than or equal to 6. Divide both sides by 3. X is greater than or equal to 2, right? Okay, so any number bigger than or equal to 2 is also going to be a what? A solution to compound inequality. Okay, all right, now you graph each one individually. It helps you to do this, and I'm on the worksheet, I do want you to draw each one individually. So negative 2 is going to go first, 2 is going to go second. Bracket or parentheses of negative 2. I'm sorry, closed circle, open circle. Close, going which way? To the right. Okay. X is greater than or equal to 2. It's right here. Open or closed? Going which way? The right. Now, before I go on, if this was an AND statement, what would be your solutions? Where the intersects will be from where? No, not negative 2. Positive 2 to infinity. That's where they intersect. They don't intersect here. They intersect here. If that was an AND statement, remember I said if this was an AND statement. All right, now this is an OR statement though, right? So anything shaded is a solution. So you go from left to right, and you kind of, remember these little vertical lines right here? You kind of shade them in. So where do I start putting this vertical line? Negative 2. Anything shaded solution. So negative 2 all the way to what? Infinity. That's what's being shaded. And so your final graph then, on the number line, you're going to say negative 2, open circle, closed circle. And you're going to shade in everything that's where? To the right, with an arrow.
Why does it negative 2 and 2 overlap?
Why what now?
Why does it negative 2 and 2 overlap?
Because 2 is right here, negative 2 is right here.
Right, but they're both greater than, and negative 2 is across, because they're not on the same line, because you're doing two different graphs. I'm
graphing the first inequality, I'm graphing the second inequality. If this is an AND statement, I would want where the two graphs intersect. It would intersect here from 2 to infinity. That would be the solution to this was an AND statement. This is an OR statement. So an OR statement would be anything that's shaded. So anything shaded is from negative 2 to infinity. What would be the interval notation?
Bracket, negative 2, comma, infinity.
Parentheses, right? Remember, parentheses in infinity, negative infinity is always parentheses. Okay, let's look at, let's see. All right, let's do one more. Let's look at, oh, did y'all see, did this one have a union? No. You understand this, right? This did not have a union. This one did because your graph was made up of how many parts? 2. Your solution is made up of 2 parts. Here your solution is just 1 part, so no union, right?
Correct.
Okay. Let's look at 42. You have x plus 9. Yeah, x plus 9 is less than 0, or 4x is greater than negative 12. Remember, this is a compound inequality with the word or, so anything that's shaded is going to be a solution. Here you're going to subtract 9. So the solution to that first inequality would be any number that's less than negative 9. In fact, since this is an OR statement, any number less than negative 9 is the solution to this compound inequality because it satisfies this one. Over here, how to get x by itself? So x will be greater than a negative 3. So any number bigger than negative 3 is the solution to that one, but it's also a solution to what? The compound one. Because remember, it's got to satisfy at least one of them. All right, but then you graph each one individually. So on the number line, do I put negative 9 first or do I put negative 3 first? What goes here? Negative 9. What goes here? Negative 3. Okay. Less than -9, open or closed? Going which way? To the what? To the left. Next one, x is greater than -3. Here's -3, open or closed? Going which way? To the right. If that was an and statement, what would be the solution?
None.
None. No solution because they don't overlap. But this is an or statement, so anything shaded is a what? Solution. So is this going to be the word, the symbol union, or just two intervals or one interval, do you think?
Union.
It'll be the union because it'll be two intervals. You're going from, remember, anything shaded. You're going from -infinity all the way to what? -9. And then you're going from -3 to infinity, two intervals. So the graph, so you're going to shade in like this all the way to -9 with open or closed. Don't forget your arrow though. Put your arrow. And then you're going from where? Open or closed. Don't forget your arrow. So that's your graph. Interval notation, you're going to say what? -infinity to -9, parentheses, union, parentheses, -3, comma, infinity. All right? So that's all that is. Now, there are a couple more we're going to do in this section. And we'll do that next Thursday. So Tuesday's your test. So you have the study guide, so make sure it's, and remember your test 1 is 40% and the new material is 60%. Okay, so it shouldn't be that difficult. The only word problem part that's on your test comes from which part?
9.4.
There are many parts of 9.4. Which part of 9.4?
Right.
9.4a. That's on your study guide. Okay? And those are the easy ones because it's just translation word problems. So where it says your unknown, you're always going to say let x equal what? The number. For that part A, that's all you have to do in each one. Let x equal the number, let x equal the number, let x equal the number. Okay? All right.